Okay, this question right here. I'm going to see if I can enlarge it a little bit. I can get away with that much. Nah, probably not. Probably better stick with that. Okay, so anyone need to see this one work? Okay. Basically, you distribute. The biggest thing is don't forget to distribute that to both of these. Yes. No, I did not intend to send this to you. Although you can watch it on video for 3 days. Or 4 days, I think it is. It'll disappear from YouTube in 4 days, on Friday. Okay, so second problem. Look what we got here. Anyone need this one? Yeah, I thought so. Lots of people missed this one when we did this. Okay, when you got this situation, you got two problems. Okay. You got this side. Okay, whoops, didn't give myself enough room. -6 less than 3x minus 1. And you got this side, 3x minus 1 less than 5. Okay. And then we just have to work these two problems. Well, let's take this over to the other side, +1 + 1. So we get 3x. Symbol still stays the same so far anyway. And we get -5 here. Divide both sides by 3. And we get x is greater than -5/3, or x is greater than -5/3. This is the one we're going to use if we try to graph this thing. Always with the variable on the left if you graph. Okay, this side. +1 + 1, 3x less than 6. Divide both sides by +3, x less than 2. Okay, so we've got these two answers. Okay, what that means on the number line, here's 0, is here's -5/3, which is 1 2/3. Here's 1, here's 2, here's 1 2/3. And here is +2, 1, 2, right there, 2. Now, what is this saying about these? This one is saying that its numbers less than 2. That way. What is this one saying? This one is saying its numbers greater than that one. So what's my solution then? Everything from here to here. So in interval notation, our answer is -5/3 to not inclusive, because there are no gaps in this piece. Okay, and here is obviously our graph, although the problem didn't tell us to graph it. It's much easier to get the interval notation if you graph it. Say again? This would be your answer in this case. The internal interval, easy for me to say. Did you have a question?
Yes, but
Go ahead.
The
The dots.
Right.
Oh, here? Well, in grade school, yes, those would have been open circles because we use those in grade school. In college algebra, you will have to use the brackets and parentheses. So I'm wanting you to get used to it. Okay. And by the way, welcome to Frida, right? No, wrong name. I've got you confused again, don't I? I have a student in my online class who said she might come tonight. And they're dead ringers for each other. Doppelgangers, I think they call that.
Yeah.
Okay, well, any questions on this one? Did I answer yours? I answered yes, but don't do it. Don't do that, that's contagious. Okay, here we go. Absolute values. What happens when we have absolute values? Two problems again, a plus or minus. Here's the plus side, here's the minus side. 4x minus 3 equals 11. And 4x minus 3 equals negative 11. Okay, so plus 3, 4x equals 8, divide by 4, and x equals 2. Okay, over here, plus 3, strange looking plus, 4x equals negative 8.
Yeah.
Where? Oh, yes, this should be 14. Thank you. Yeah, I did that on purpose to see if you were paying attention. Right. Okay, so 14 divided by 4. Now this problem gets ugly. Equals 7/2. Or 3.5. Okay. Well, now I can try to continue over here since I'm so distracted now. I think I'm right this time.
Yes.
Okay. So I've got those two statements. Now, what do I do with those? Well, if they ask you what are the two solutions, you could write x equals 7/2. That's a 2, comma, negative 2. You could put them in braces, 7/2, negative 2, like that, and either of these two answers would be accepted.
What if it doesn't have any wording, it just has the top like that?
That would be your final answer. Okay. This is an equal, so these are specified points, not a range, like if you have less than or greater than. Yeah, like the problem below it. This will probably be the last one we do tonight. I'm guessing, unless you guys just really want to do the next one after that. I mean, we don't have to do this one if you don't want to. It's up to you. Okay, this and we'll go on. Okay, anyone want to see this one? Yes, did I hear a yes? Okay, good. All right, so two problems once again. 6a plus 2, oops, I better spread this out. 6a plus 2 less than or equal to 8. Here's the important part. 6a plus 2 greater than or equal to negative 8. Here's the minus side, here's the plus side. Remember, on the minus side with less than or equals or greater than, you got a flip symbol on the minus side. So that's the critical step in this problem. Plus 2, 6a less than or equal to 10. Okay, divide by 6, divide by 6. A less than or equal to 5/3. Okay.
You should have subtracted.
We did it.
Did it again, didn't I? Okay. Well, let's make that a 6. Actually, it's going to make this a much nicer problem. Much nicer problem. Okay, over here, minus 2, 6a greater than or equal to negative 10. Divide by 6, divide by 6. A greater than or equal to negative 5/3. Okay. Now, we can't just write 1 and negative 5/3 like we did the other one because these are inequalities. So we have to do an interval notation. And the easiest way to do that is to graph them. So this one, here's 1. And this is greater than or equal to 1. So, or less than or equal to 1, I mean. So brackets, arrow this direction. This one, here's positive 1 or negative 1. Here's negative 2. Negative 5/3 is 1 2/3. Okay. It's got the or equal and is telling us is everything bigger this way. So then our solution is that graph. So that tells us what our interval looks like. Negative 5/3 and 1 box. I knew we had done an absolute value inequality, but in this one, we'll go ahead and start there. All right, so in this case, we're going to get rid of the absolute value, but that creates the two problems again. X minus 13 greater than or equal to positive 9, and X minus 13 less than or equal to negative 9. You have to, and I want to remind you again, not only do you take the negative side, but you also have to flip symbol on the negative side. Now, from there, we want to take the 13 over to the other side. So we get X greater than or equal to positive, what, 22?
Yeah, here.
Okay. So that's our value there. If we graph that on the number line, at 0, here's positive 22. And the graph of that is all things greater or equal. So we're going that direction. Now, for the negative side, once again, we move the 13 to the other side. X less than or equal to, in this case, positive 5 or positive 4. Okay, so we graph that. Here's positive 4. And in this case, it's everything less than or equal. So it's everything this way. Now, that's your completed graph on this one. As you see, there is no overlap on this one. So basically, this one is an or statement or a union statement, because we have the gap here, we have a union in our interval notation. So then the interval notation looks just like this, 22 to infinity. And on this end, 4 to negative infinity. What?
I forgot my bracket.
Yeah, makes a difference whether it's a brackets or parentheses. Any questions before I go on?
I don't know why, I thought you said you forgot it.
Oh.
I do have a brace on my foot, and I don't do that. Good, see, there you go.
Well, I guess you didn't know the math could be brace based. That was pretty bad.
So there used to be a cartoon called.
I know. Okay. Graph that equation. Well, first thing I need to do is I need to draw an XY axis on here somewhere. So I'll make that the X axis. I'll make this the Y axis. Okay. And this one's actually pretty easy to graph. -3 is my y-intercept, 1, 2, 3 right there. This is the point 0, -3. And then my slope is up 2 over 1. So from here, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, or down to the other way 1, like so. And then you draw the line. Okay? That's really all we have to do on that one. Questions? So what did we do? We took the y-intercept as our anchor point. And then our slope tells us up 2 over 1, up 2 over 1, because this is rise over run. In case you're wondering what that green circle is about, that's the hot spot on my video recording that I don't want to put anything in that circle, because I had a student email me out of my online class and, Mr. Carter, can you tell me what number 1 was, or number whatever problem it was, that the problem was in the middle of the hot spot. She couldn't read it. What?
The stand. So much smaller.
Because it was on, it was.
Well, because I raised it up and brought it closer, because I'm not going to be using that part of the board for this.
Okay.
Whiteboards, you can't screech your fingers. Okay, here we go. Well, this one, there are two ways we can graph it. If they say graph the y-intercepts, okay, if they say graph the y-intercepts, then what we have to do is substitute x for y, or 0 for y, find out what x is, then let z plug, and then plug in 0 for x and find out what y is, plot those 2 points and draw the line. So if we do that, okay, x, y, let x be 0, let y be 0. If x is 0, then that wipes out this whole thing. So 3y equals 12, y equals 4. So we've got the point 0, 1, 2, 3, 4. Okay. If, say what? Well, if that's 0, wipes out all of this, divide both sides by 3, 3 goes into 12 4 times. Okay, now we're going to let y be 0, which wipes out all of that. So negative 2x equals 12, and we get negative 6. So in this case, we get the point 0, negative 6, or negative 6, 0, 1, 2, 3, 4, 5, 6 here. And we draw the line. Okay. The other way of doing this is much easier, I think. Put this into y-intercept form. 3y equals positive 12, positive 2x plus 12. In other words, I'm taking this onto the other side. Okay, and divide every term by 3. Y equals 2/3 x plus 4. Well, in that case, then 4 is my starting point again, my y-intercept. And I go up 2, 1, 2, and over 1. If I drew this line correctly the first time. To make this work, I've got to draw the line right. Yeah. In either case, if you draw it correct, and I still didn't go perfectly through my corners. That's why you're supposed to use a straight edge, which would be awkward in this case. Okay, so all of you are going to have your ID with you. So all of you are going to have a straight edge. Use it. But here's 2 different ways of graphing that same equation. If they say give the intercepts, not only do you have to do it this way, but you have to label these 2 points. 0, 4 is the y-intercept, and negative 6, 0 is the x-intercept.
Are we allowed to bring a ruler to the test?
Just use your ID, it's good enough.
Okay.
I mean, a ruler's going to be big and awkward. Okay? The graphs aren't going to be any wider than this. The graph paper that I give you. Say again.
Braden's gonna hate me. Oh, are you grading them?
He's grading
Oh,
them.
God.
Be calm, be calm. Okay, given this function, remember this is y, equals that. Find f of negative 3. What are they asking you to do? just a substitution. They are saying, put -3 into this equation and substitute it, or substitute it into that equation. So I've got 4 minus 3 times -3 minus -3 squared. Okay, well, this is 4 plus 9 and minus 9 squared. Okay, so here 9 squared is 81.
Why
is
the
square
square
not
always-
square?
I don't know why, you know.
I'm like, the square should.
Okay, minus 9 and plus and 4, and those two conveniently go away. So the answer is 4 equals f of -3, and you do need to label it that way.
Would be 4 and
You can flip sides on that. That's no big deal, if that's your question.
So if we put X as Robinson.
Technically, yes, because it has asked you to find this value. Anyone not ready for me to erase? Good thing the semester's about over, because these markers are about over too. They're starting to get faded. Find the domain. When it says find the domain, that means what can that denominator not be? Okay, what? Well, it can't be 0, but what numbers could make it 0? Well, maybe, maybe not. 4x plus 5 equals 0. If it can't be equal, it can't be 0. You set it equal to 0 and figure out what it can be. Minus 5 minus 5. 4x equals -5. Divide by 4, divide by 4, and x equals -5 fourths. Now, that's the number it can't be. Now, if they ask you to put this problem in interval notation, the answer, and there's a 50% chance they will. Okay. Then in interval notation, this is a value it can't do. That means I've got to have a union right there. Piece of graph paper. Here's 0. Here's -5 fourths. Okay. This is saying it can't be that value. So what can it be? It can be anything this way, and it can be anything this way. Right? But it can't be that one. So when we write in interval notation, any place we have a gap, and there is a singular value gap there, we have to use a union symbol. And in this case, it will be a parentheses because we cannot include that -5 fourths. From here to infinity, and in this one, -5 fourths to -infinity. So that would be the interval notation if they require it. And like I said, there's probably at least a 50% odds that they will.
If we write it in a union form, when they don't ask for it, this would be safe, but we still get the credit for it.
Absolutely. Okay. It'd be foolish for me not to credit that. Find the slope and y-intercept of that equation. That's a pretty easy question, actually. Okay. This is standard form. We got to isolate that and put this in. That format. Okay. So -4y equals -5x minus 8. I took that over to the other side. Now I'm going to divide everything. Well, I dropped both black pins down by -4. By the way, if this had been a less than or greater than, and we divide by a negative, we would have had to do a flip symbol. It's not, but if it were. Okay, so what do I end up with here? I end up with 1y. And this becomes +5/4 plus 2. So in this case, this equation is not my answer. My answer now is M equals 5/4. The y-intercept equals the point 0, 2. And y-intercept always has to be in point form if they ask for the intercepts. It's picky stuff, I know. I mean, you get this far, you're going to get 3 points. But 4 is better. Any questions before I go on? Oops, I gotta drop that down a little bit. Find the slope of a point containing this and this. The slope formula, M equals y2 minus y1 over x2 minus x1. In other words, rise over run. Okay, every year I have some people get that thing upside down. Now, I choose to call this 0.2, and I choose to call this 0.1. That way I can just go left, right, left, right. Okay, so let's do the y's. 5 minus -2 over -3 minus +4. See how much easier that is when you just go left, right, left, right. Now, from there, we're going to do this. So 5 plus 2 is 7. -3 minus 4 is -7. So this thing equals -1. So your final answer then, M equals -1. Anyone not ready for me to erase yet? Okay. I'm gonna go ahead and scroll the problem up. Ready for the rest yet? See this, find the equation of a line statement? Anytime you see that, eventually, you're gonna use this equation. Now, you may or may not have a first step first, if you have to find the slope. But in this case, we can get the slope because of this thing. Okay? Now, this one says parallel. What do we know about parallel slopes? They're the same, right? So if slope number one is -2/3, then slope number two is also going to be -2/3. So now we're going to use this slope with that point and that equation to answer this. Y minus y1, 3, equals the slope, -2/3, times x minus the x value. Okay, so first thing I do is that, and then I'm gonna distribute this thing, so I get y minus 3 equals -2/3 x. And 2/3 of 6 is 4. Anyone need me to show you that? Negative makes positive. Oh wait, this one's negative. So yes, it would be negative. I've got 3 negatives. So it would be negative. All right, so now we want to take this over +3, +3, and consequently we get y equals -2/3 x minus 1. And that's the final answer. Any of you ever thought about bringing multicolored pencils? It's actually not a bad thing to have in math class, as long as you don't get so intent on trying different colors that you lose track of where you're going.
So if it's parallel to a line, does that mean it's always gonna be the plus and minus in the original answer?
If they're parallel lines, whether it's straight up and down, or at this angle, or at that angle, or whatever, the slopes are gonna always be same. Okay? If you have this line, here's a piece of graph paper, you have 2 parallel lines. Up this many and over that many, up this many and over the same many. Okay? And that's just the way it'll, well, in this case with a negative slope, they both be going downhill.
I'm talking more about the b and the y equals the y equals 2x or 2/3 x plus 1, and the final answer is y equals negative.
This is a coincidence that they're both ones. Yes, that is a pure coincidence. More often, they won't be the same value, but even regardless of the time,
That's you.
okay?
Don't have your nose? Don't know how.
Now, for example, let me draw an illustration of that. Let's say that this was the first equation. I actually, I got pretty close there. That's the y-intercept on this one. If I had an equation right here, well, then I would have on the end a -2. If it were parallel right here, I would have like a -8 or whatever it is. If it were up here, this last equation would have maybe a +12, for example. Okay, so the ones were just a coincidence.
Yeah, I totally clarify.
If they are parallel.
If it's
Now,
perpendicular.
if they are perpendicular, that's the symbol for perpendicular, then slope 2 would be +3/2. Whereas the first equation went this way, the second equation would go that way. Somewhere. Ta-da. Okay. So we'll play their little game. Y minus y1 equals m times x minus x1. Write that down. It's worth 1 point on this problem. Okay. Now, in this case, our original slope is -2/3. Okay. Our perpendicular slope, notice how I'm labeling this to myself. Original slope, perpendicular slope is going to be, I forgot my equal sign there, is going to be +3/2. So in this case, I'm going to put 3/2 here. X minus 2 and y minus -5. Y plus 5 equals 3 as x minus 6 halves. Y plus 5 equals 3 halves x minus 3. Now I want to take this 5 over to the other side. -5 minus 5. So I get y equals 3 halves x minus 8. Question? Question? Okay. Systems of equations. There are two ways we can solve it, by the addition elimination or by substitution. This particular one, I'd probably do it by elimination. I have to find an opposite pair. Well, if I've got opposite signs here, so I might as well take advantage of that. What do I need to make both of these so I can have an opposite pair? Make them both 12s. So I have to multiply this equation by 4. And I have to multiply this equation by 3. Okay, when I do that, I get 8x minus 12y equals 20. And this one, I get 9x plus 12y equals negative 3. So I can add them. These two go away, and I get 17x here, and I get 17 in there, very conveniently. Divide by 17, divide by 17, x equals 1. That's my first answer. Questions before I go on? Okay, for my y value, I can use either one of those. I'll just use the top one I get. No, I'll use the bottom one because it's already positive. 3x plus 4y equals negative 1. Okay, I'm going to replace the x with 1. 3 times 1 plus 4y equals negative 1. So 3 plus 4y equals negative 1. Now, can you switch, go straight from here to here? Yeah, you can. I'm not encouraging you to, but you can. Let's take this 3 over to the other side. Minus 3 minus 3. 4y equals negative 4. Divide by 4, divide by 4. Y equals negative 1. That's my other answer. So my final answer then is the point 1, negative 1. Okay. Now, what if we wanted to work this one by substitution? Everyone got this one down so I can erase this word? We're doing the same problem with substitution. I could have left the answer up because it's going to be the same. You know what? I think I'll use this one as my substitution equation, and I'll change it to 2x equals 3y plus 5, and ultimately x equals 3 over 2y plus 5 over 2. Okay. Now, let's go into the other equation. 3 times that plus 4y equals negative 1. This is kind of an ugly problem. 9 halves y plus 15 halves plus 4y. 8y/2. Common denominator. So I took this one times 2/2. Okay. For a common denominator. Equals -1. Okay. So these two combined and give me 17/2 y. This gives me plus 15/2 equals -2/2. I'm playing common denominator again. Okay, got the same denominator everywhere, don't I? So that makes this problem into 17y plus 15 equals -2. Okay, so in this case, take the 15 over, minus 15 equals, and minus 15. So I get 17y equals -17. Y equals -1. Same as we had before. Remember we had 1, -1. Okay. Now, do I need to take this -1 and put it back into either one of those for you? Okay. That one was kind of a nasty little one in for substitution. Oh, that wasn't awful. That was just nasty. I haven't shown you awful. Okay, what do we got here? I better lower that one notch. There. Motorboat, motorboat. Those 3 hours with a 2-mile-an-hour current helping it. There used to be a little book that started off like that.
No, they have.
A children's book.
Yeah, they have.
Oh, okay, calm down, guys.
Oh, boy. I do.
Coming back takes 4 hours. What's our basic formula? D equals RT, right? Well, the distance is going to be the same on both of these, right? Distance is going to be the same. So the distance with the water or with the current, okay, is going to be whatever the rate is, the current, R equals the boat speed rather. Okay, time and distance. Now, so for going with the current, our answer then is we have the boat speed plus an extra 2 miles an hour times 3 hours. D equals R, the added on R times time. Okay, our other equation against the current is going to be R minus 2. And I told you before, what you giveth, you taketh away, times 4 hours. Now, because this distance is the same both times, listen carefully, because this distance is the same, then this equals that. What? You understand that? Or why? They're the same distance. What if I put 50 here and I put 50 here?
Okay.
We don't know what the distance is, we just know it's the same. Because they went and they came back, okay? So then that means this equals that. Or in other words, R plus 2 times 3 equals R minus 2 times 4. Well, this gives me 3R plus 6 equal 4R minus 8. Those are problems like we did the first week, like we did with my equation chain. So we're going to take that over there and going to take this over here, minus 4R, minus 4R. And then over here, we're going to take plus 6, excuse me, minus 6 and minus 6. Doing all of that, I get a negative 1R. Those cancel, equals, those cancel, negative 14. Divide both sides by negative 1. And we end up with R equals 14 miles per hour. Gotta put the label. Okay? And that's all we have to do here. Because that's all this question asks. Now, what if this question asks, what is its speed going uphill and what are downstream and upstream? Well, then you'd have to take 14 plus 2 and 14 minus 2. Okay? If it asks that. I'm trying to explore all the possible ways they could work the problem, is what I'm trying to do. You look a little uncertain.
I think these kind of questions.
Well, that's, pardon me, but that's irrelevant.
No, I know.
Well, just remember, if it's, I don't care whether it's an airplane flying through the sky against a current, a speed of wind, or with a wind, it's going to be this kind of a speed. Okay? It's always going to be that way. And your D equals RT is going to be your basic formula. Now, I suppose it's possible they could change the distances of one, and then you would have to use a proportion to solve it. But same kind of things in the same kind of places. But they're very unlikely to do that to you. At least in this class. Okay, we got a couple of inequalities to graph. I guess the first thing I need to do is I need to put my X and Y axis up here. Okay. Now that I've got that, what have I got to do? Graph each line separately. See if they intersect, if they're parallel, if they're whatever. Okay. Or even same line. And then we have to shade the overlapping area. Okay, now, neither one of these are in y-intercept format. To read whether you shade above or below or left or right, you need to put these in y equal mx plus b format. So let's do that. X plus y greater than or equal to 4. So y greater than or equal to negative x plus 4. Okay. The other equation, x minus y less than or equal to 2. So negative y less than or equal to negative x plus 2. Divide by negative 1, divide by negative 1, divide by negative 1. Y greater than or equal to because when you divide by a negative, you got to flip symbol. Positive x minus 2. Okay, so I've got this equation and I've got that equation. I'll graph this one first since I got the red pen in my hand. Now, first of all, am I going to use a dashed or a solid line? Why? Because it's equals. Okay, here's negative 2, my y-intercept, and my slope is 1 over 1, right? So I go up 1 over 1, 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 down 1 over 1, and so on. So here is my line. Now, do I shade above or below that line? Why?
Y is greater than.
Because this says I want y values bigger than anywhere they are on the line. So this is everything up here. Now let's do the other one. I'll do it in blue. Positive 4, 1, 2, 3, 4. Okay. And my slope is negative x, so that means I've got a negative 1 over 1 or 1 over negative 1 for my up and overs. Okay, so from here I can go up 1, left 1, up 1, left 1, up 1, left 1, or down 1, right 1, down 1, right 1, down 1, right 1. I do have a point of intersection there. Actually, if you look at it, no, they're not. Here we go. So here is this line. And it's solid also because of the or equal. Now, where do I shade on it? Up here, right? Correct? So here, like this. Yeah, whack myself in the head with a pinball. What? Okay, right here, y is 0. Where is y greater than 0? Right there, and 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 right there. Where is y greater than here? Right there, right there, right there, right there. That's why it's up there. Now, what is the overlap in this case? Anything above the blue and anything above the red. Or in other words, this area. I wonder how well that's showing up on my graph. Well, it's tolerable. Not great. Question on this one? Okay. Got a lot of erasing to do on this one. For 17 and 18. Okay, they just want me to subtract these two and multiply those two. Okay. So, what do I gotta watch out for most of anything? That negative right there. Okay, that minus in the middle. This one I can just write down. Minus a negative gives me plus 2a squared. Minus a negative gives me plus 3a. Minus a negative, let me draw this way. Okay. And minus a positive gives me -4. Now I can combine like terms. I've got a squares. So 6a squared. I'm going to check those two off.
Minus 2a.
I've got a -5a and a 3a gives me a -5a. I'm going to check them off.
Negative 2a.
And, oh yeah. And these two give me a -3. Done.
I like this one.
Okay, this one is just distribution. I'm going to take this times this and this times that. And that times that and that. So 4y times 3y is 12y squared. Now that one plus 8y. Now in my second line, -5 times 3y is -15y. And -5 times +2 is -10. Okay, so I'm ready to add those together, and I get 12y squared minus 7y minus 10 box. Okay, they want me to factor this ugly thing. 6 goes into all of those. X also goes into all of those. So 6x comes out, leaving 4x squared plus 1x minus 8. Okay. Now, I'm just going to bring my final answer over here, 6x and that. I better lower that a little bit. What do I know about my signs here? One of them's going to be positive, one of them's going to be negative, isn't it? Okay. So when I try to factor this thing down here, I'm going to have to do a subtraction. Well, what are the factors of this? 1 times 4, 2 times 2. What are the factors of 8? 1 times 8, 2 times 4. That's pretty much it. Well, I'm going to be lazy and try 2 and 2 first from up here. Then I'm going to try one of those. I'm going to subtract and I'm going to get a very small number. Okay. Well, if I put the 2 and the 4 here, Here I get 4, here I get 6, and I subtract and I get a 2. That won't work. Well, if I put the 1 and the 8, here I get a 2, here I get a 16, I subtract and I get a 14. That won't work either. So the 2 and the 2 don't work. So now I can try either of these combinations. Well, what if I put the 2 here and the 4 there? Here I'd get a 4, here I'd get an 8, I'd get a 4. That will work. Okay. Whoops. Didn't mean to do that. Well, what if I try a 1 and an 8 or an 8 and a 1? Here I get an 8, here I get a 4, there I get a 4. Guess what? This is the answer.
I don't have to find a zero, it just says that.
Yeah, it doesn't have equal 0. So we can't use the quadratic formula.
So that
Oh,
is
maybe I
factor.
don't.
That is factor. You guys are thinking, oh shucks, or something worse. All that work for nothing. Well, I'd have to agree with you. Okay, this one. It's a cubic, I've got 4 terms. Can I combine anything? I don't see anything there I can combine.
No, but you can break it down into different factors.
It's called factoring by grouping.
That was lesson.
I'm just gonna try this way. Actually, I would put that and put the plus there. Okay? If I do that, on this one, I can factor out a y squared, leaving y minus 6. Plus, I can factor a 3 out of this, and y minus 6. Ding, works. Pull that out. Times y squared plus 3. And in this case, that thing won't factor. That will not factor, because that's not a perfect square on that end, and that's not a minus. And we don't have equal 0, so we can't use zero products rule. Our square roots, properties of square roots. So we're done. As far as we can take it. Now, I told you guys when I started this second batch of stuff, if there were problems you wanted to just skip, let me know so we could progress, because I actually have a choice of 50 questions here. Obviously, we're not going to get to number 50. So as I pull up the problems, start looking at these selectively, whether you would like to see them worked or not. Okay, what about this one? Anyone want to see it? It's a conjugate, perfect square on the front, 4b, and 3. Yeah, okay. What about this one? You want me to write the answer on this one anyhow? Okay, this one. This one's not all that nice. You want me to factor it or not? Okay. 1 and 2 is the only possibility there. Over here, I got 1 times 12, 2 times 6, and 4 times 3, or 3 times 4. That's a 3, not a 5. Strange looking 3. That's going to tell me that my final answer has to look like this. It's also going to tell me that down here, I'm going to subtract. Okay. You say the 4 and the 3 work? Okay. Does it matter? It does, because these aren't the same number. So the 4 here, the 3 there, I get 8. I get 3. You subtract them, I get 5. Now, to determine which one goes with which sign, this 5 has to be negative. So the biggest of these two has to be negative, which comes up here. And this one comes there with a plus. So my answer then is x, 2x plus 3 and 1x minus 4. Okay, yay or nay? Okay, the answer is nay, apparently, but the answer on this one is going to be x minus 3, x minus 3, or x minus 3 quantity squared. Okay, this one, got to take that over there, so it ends up x squared minus 2x minus 24 equals 0. This is one we got to finish out. Get x equals, not just factors. Hint that word. Okay, see, this one didn't say solve. Now, this thing factors. 8 and 3 won't work. 6 and 4 will. So this one's going to factor into x minus 6, x plus 4. How do I know which one goes with which? The bigger number has to have that sign. Equals 0. So x equals positive 6. And x equals negative 4. And you can write it that way, or you can write it 6, negative 4. Don't think they'll put a problem like this one on the test, but they could. Like I said, I haven't seen this year's test yet. Helps to draw a picture. Okay, this thing is 48 square feet. Okay, what's the formula for area of a rectangle? Area equals length times width. Okay. What do we know about these? Says it's 2 feet longer than it is wide. Okay? So the length is W plus 2. Okay? Is 2 feet longer than it is wide. The wide is what it doesn't tell you anything about. That's why it's your variable. Okay, so now I just need to simplify this sum. Area equal W squared plus 2W. And we know that the area is 48 square feet. So let's take this 48 over to the other end and get 0 equals W squared plus 2W minus 48. There's an equation we can factor. So 8 and 6, right? 6 times 8 makes 48. 8 minus 6 is 2. So that means this thing factors into W minus 8.
Plus 8.
W, yes, plus, thank you. And W minus 6 equals 0. So I get W equals positive 8, negative 8. And W equals positive 6. Ding. Can't have negative distance. Can't have negative distance. So the width is 6. Now, given that this width is 6, we go back to our original formula here, plug in the 6 here, the 48 here, and it equals L equals positive 8.
With 6.
But am I done? No, no. 6 times 8 is 48, it checks. The dimensions are 6 here, 8 here. Ding. So your length is 8 what? Feet? And your width is 6 feet. Now, actually right here, because I've already kind of defined that, as long as I had written feet here and I had written feet here, I probably wouldn't take off points.
Okay.
What? I figured you guys could use a little fractions problem practice.
Oh,
Yeah.
appreciate it. How sweet.
You know my favorite Christmas jingle, don't you? Real numbers, rational numbers, fractions all the way.
Oh, my.
Oh, what fun it is to write math problems every day. Hey,
That's when you know you're on that.
actually, I made a whole set of math carols. We used to go math caroling with my students the last day before the break.
Okay, let's go.
Okay, this one is division. This one is division. So flip this. So 16x², I'm gonna move this out here. 16x² minus 25 over 6x³ minus plus 18x² times 4x² plus 7x minus 15 over 4x² minus 7x minus 15. Now I gotta factor everything. Okay, this one factors into 4x minus 5, 4x plus 5. That's a conjugate. Perfect squares on the front and back, minus in the middle. This one factors into 6x² times x plus 3. This one factors into, that one's not so easy. I might have to go over here. I'm gonna do a piece of scratch paper on this one.
1435, so it's 1.
So I'm gonna try 2 and 2 first, and 3 and 5. And I'm gonna have to subtract. So here I get 10, here I get 6, there I get 4, that won't work. Okay.
X plus 3, 4x minus 5.
Let's try the 1 and 4 and the 3 and the 5. Here I get a 5, here I get a 12, I get a 7. Okay, so I got it. And my biggest has to be this one and that. So here are my signs. So I've got, what is this? X plus 3 and 4x minus 5. Okay, then I got to do this one down here. The same thing, only different signs. So this is, as he said, x minus 3, 4x plus 5. Now, you notice how I factored these above and below. Okay, let me get rid of this scratch paper now. Okay. Now let's cancel wherever we can. This x plus 3 cancels that x plus 3. This 4x plus 5 cancels this 4x plus 5. Do you see anything else that'll cancel?
No.
4x minus 5. They don't cancel for the same stuff.
They're on the same level. They can't cancel. So this thing equals then 4x minus 5 squared over 6x squared times x minus 3. And there ain't anything down here that's going to cancel anything up there. So this is my final answer. But you've got to check to see if you multiplied those out, if that would happen. In this case, it won't. Okay, so It's time to go. We got halfway through this batch. Hopefully that problem right there may be a help to you. Yeah, we did those back around